Students, I'm Sonali Kelkar from City International School, and today we are going to do the second revision of science. Before I start with the revision, I just want to inform you one thing. We have done a project on environmental impact assessment. That is the only project we have to do for 10th grade, and that is what is art integrated project is. Okay, so as such, we are not doing any art integrated project. The project that we have done on environmental impact assessment, that will be considered as a project. And please avoid the mail that you got on the structure of atom that was given to you by mistaken. So please avoid it. So let's start today's session, children. So question number 1. What will be the amount of energy available to the organization of second trophic level of food chain if the energy available at the first trophic level is 10,000 joule? Okay, so first trophic level, the energy is available. And what are present in the first trophic level? Plants are present. Plants are present in the first trophic level, right? Now, remember here one thing. Okay, plant is going to absorb 1% of the energy that it is that what plants are getting initially. Okay, so plants are going to take 1% of energy, and if this energy goes to the second trophic level, that is going to consume 10%, right? And then other 10% and so on, right? But the plants are going to consume 1% of energy. Please remember this. Okay, now let's start with the answer. So according to 10% law, only 10% of energy entering in a particular trophic level of organism is available for transfer to the next higher level. This is a very important question, children. You have to keep it in mind, all the points which we have discussed here, right? So here the energy level for the first trophic level is 10,000. So please make it as a 1% of this energy. What is the 1% of 10,000? You have to find out. That is 1 upon 100 into, sorry, 10,000. So it is coming 100 joules, right? So 100 joule is going to the first trophic level. So, okay. Then from plants, it will go to the next level, that is 100 joule. And then for the second trophic level, let's find out the 10% of 100 joule. So 10% of 100 joule, let's take 10%, 10 divided by 100 into 100 joule. Okay, so this will go off, it will come 10 joules, right? 10 joules. So this is the answer for this question. So for the second trophic level is getting only 10 joules. Question number 2, the first trophic level in food chain is always a green plant. Why? Because green plant is a source of food. Okay, green plants are the only organism which produces their food, and that food is further utilized by the other animals. Green plants as a autotrophic, they produce their food and gives that energy in a form of a chemical that we consume, heterotrophs, right? So that is why green plant is always on the first trophic level. Just read out the answer. The first trophic level in food chain is always a green plant because green plants have a mechanism for trapping solar energy with the help of their green pigments called chlorophyll and convert into chemical energy. What is the chemical energy over here, children? It is starch or glucose. Okay, initially whatever food is formed, it is converted into glucose, and then immediately it changes into starch where it is stored in different parts of the body of plants, right? So let's see the next question, children. Here, write one negative effect on the environment of affluent lifestyle of a few persons of society. Affluent lifestyle means we are releasing continuously an unwanted thing in the environment. The unwanted thing are nothing but the pollutant, isn't it? So when we are continuously throwing unwanted thing in the environment, what will the negative effect in the environment? So let's see the answer. Excessive use of air conditioners, what will happen? The affluent, okay, emits a lot of heat in the atmosphere. That is not also good. Excessive use of packaging material, especially thermocol, which is in most of the countries is banned, okay, because it's not a biodegradable. So packing materials which are mostly made up of non-biodegradable material are not environmental friendly. Then excessive use of petrol in vehicles also causes pollution, air pollution. We are well aware of this. So thus affluent lifestyle results in the generation of excessive waste material. Coming to the next question, list any 4 disadvantages of using fossil fuels for the production of energy. Of course, we know that fossil fuels are a non-renewable source of energy, so it will get exhaust after some time. But when you burn fossil fuels, there are certain gases such as sulfur dioxide, nitrogen oxide, which are acidic gases. Why we call them acidic gases? When this sulfur dioxide and nitrogen dioxide mix with water, it gives a sulfuric acid or sulfurous acid and nitric acid. So it is responsible for acid rain, and acid rain is very harmful for our skin, for hair, and even for the soil. Then burning of fossil fuels also produce smokes which pollutes the air. Then the burning of fossil fuels, especially coal, leaves behind a lot of ash. So this is also harmful for the environment and definitely is going to harm our health also. Coming to the next, in a food chain, if 10,000 joule of energy is available to the producer, how much energy will be available to the secondary consumer to transfer to the tertiary consumer? Okay, now let's see, there's a little change in this question, which is quite similar to the question number 1. So definitely the first produce, at the first level we have plants. Energy available is 10,000 joule. Plants are able to synthesize only 1% of the total energy available to them. Okay, so energy produced by the producer will be, we have to put 1 upon 100 over here. So if I cut 20, I am getting 100 joule. Okay, so the primary consumer, for the primary consumer, what is the energy available? 100 joule. And the primary consumer is going to utilize 10% of 100 joule. So we have to do the 10% of 100 joule. That is 10 divided by 100. Okay, so we will cut 0 and 10 joule is remaining. Okay, for the secondary consumer, only 10% joule energy is available. Energy transfer from primary consumer to the secondary consumer, that is 10% of 10 joule. Okay, primary consumer had 100 joule. Primary consumer got 100 joule and primary consumer has used 10% of 100 joule. So what is the energy available for secondary consumer? That is 10 joule. Now what happened to the secondary consumer? Secondary consumer is going to consume 10% of 10 joule. So what is the 10% of 10 joule? This and this 1 joule. 1 joule is the energy which is going to the tertiary consumer. The 1 joule is the answer of tertiary consumer. So if you see in this chart, 10,000 joule available for the producer, that means for plants. This is plants, right? And okay, plants, then 10% primary consumer, plants. So primary consumer will be getting 10% of the 100 joule. So they will be getting only 10 joule. Primary consumer are going to use, and 10% of 10 joule will go to the secondary consumer. Secondary consumer is going to have only 1 joule. And once the secondary consumer uses 10% of 1 joule, tertiary consumer is getting 0.1 joule, right? So if you see the trophic level, there are hardly 1, 2, 3 and 4 trophic level the energy can transfer. As you go higher and higher, definitely there is very less energy available for the next trophic level. Okay, so this is how you have to do the calculation of this question. Next, write the harmful effects of using plastic bags on the environment, suggest alternative to plastic bags. So we know that these plastic bags are non-biodegradable. If it is biodegradable, no problem. But if it's non-biodegradable, they are going to cause many problems in the environment. They spoil soil, okay, they block the drainage system, and this blockage of drainage system, we know that the Bombay rainfall, whatever the tragedy happened in Bombay, this is due to the plastic bags which have blocked the drainage system, and the whole Bombay was flooded. Then a discarded plastic bag when eaten by cows, yes, and the stray animals, they can block their alimentary canal and cause harmful. They cause harm to them also. They are really harmful for the animals also, right? Bags when thrown in water bodies can cause water pollution as they do not decompose. Cloth bag or the paper bags which can be recycled are another alternative of plastic bags. Question number 7. Why is the environment of India imposing a ban on the use of polythene bags? Suggest 2 alternatives of these bags. Explain how this ban is likely to improve the environment. So just now we have discussed about the polythene bag. I would like you to go through this answer. Okay. Now coming to the chemical reaction equation, and we are going to do the important question from this chapter. Question number 1. Name a metal for each case. It does not react with cold as well as hot water. Metals which does not react with cold water and hot water. We know that what are the metals are. This is aluminium. But react with any other physical state of water. Okay. Now next is it does not react with any physical state of water. A metal which does not react with any physical state of water, that is copper. And that is why the inner body of the geyser, right, where we boil water, that is made up of copper instead of steel, okay, or instead of iron. Question number 4. Identify the type of reaction in the following example. Okay, now let's see the reaction. H2 plus O2 gives H2O. So it is a plain combination reaction. Why it is a combination reaction? Because two reactants, that is hydrogen and oxygen, are combining to form or to give one product or single substance. Okay. Coming to the next, question number 2. What happens chemically when quicklime is added to water? What is quicklime? CaO is a quicklime. So when you add quicklime to water, what happens? It changes into slaked lime, that is calcium hydroxide, and a lot of heat is produced. So this quicklime acts vigorously with water to produce slaked lime and releases large amount of heat. So this is an exothermic reaction. See the question. Here, identify the type of reaction from the following equation. Okay, the first is methane plus oxygen gives carbon dioxide and water. Student, this is not redox reaction. You can call it, because in this reaction a lot of heat is produced, which is not mentioned over here, but heat is produced. It can be mentioned in the question, and because of this, we can call it as exothermic reaction, or we can call it as combustion reaction. Okay, because in all the combustion reaction heat is produced. So exothermic reaction or combustion reaction. Okay, next question. PbNO3 plus Ki, PbI2 plus KNO3. So if you see over here, okay, lead and iodide has react together, and nitrate and potassium had reacted together. So definitely this is a double displacement reaction. Calcium oxide plus water It's a combination reaction, as well as we know that it produces a lot of heat. So you can write combination reaction slash exothermic reaction. Right. Now calcium sulfate plus zinc. Okay, displaced reaction because, sorry, copper sulfate and zinc. Copper is displaced by zinc because zinc is more reactive. So copper is displaced by zinc, or we can say that zinc has displaced copper, and we got zinc sulfate plus copper. Okay, these copper is deposited. Let's take an example. Let's take on a nail. This copper is deposited in a form of a minute particles, brown particles, right? Now, question number 4. Why is silver bromide stored in dark bottles in laboratories? While write the chemical equation to justify your answer. We know that silver bromide, when exposed to light, it decomposes, right? Here is an equation. Silver bromide, AgBr, when it exposed to light, it get decomposes. So this is a reaction of which is an example of decomposition reaction. So what happened after that? We will get a grayish white color silver, and bromine gas is being released, which is red brown in color. So what is the initial color of silver bromide? It was initially pale yellow, but later on changes into grayish white. Why? Because of the decomposition, and this decomposition happened because of the exposure of the chemical to the sunlight. Okay. Coming to the next question, when hydrogen gas is passed over heated copper oxide, when hydrogen gas is passed over, copper and steams are formed. Write the balanced chemical equation in this reaction and state the substance oxidized and the substance reduced. Okay, so copper oxide, when hydrogen is passed over the heated copper oxide, what happened? This is a typical reaction given in your book, in your textbook. So what happened? Copper is reduced because there is a loss of oxygen. Okay, losing of oxygen or gaining of hydrogen is known as reduction reaction. Okay, so copper is getting reduced, oxygen is getting removed from copper, right? And what happened to this oxygen? This oxygen is getting, it will make a bond with hydrogen, it will form water. So hydrogen is getting oxidized. Oxidized means if a element is combining with oxygen, definitely this reaction is oxidation reaction, and that element gets oxidized or molecule gets oxidized, right? So substance oxidized over here is hydrogen gas, and the substance reduced is copper oxide. Okay, children, here I have seen in the paper that you made mistake. So what you used to do, substance oxidize, substance reduced, you write copper, which is wrong. Copper is not a substance which is reduced. Copper oxide is reduced. Okay. After the reduction, you get copper. But when you have to write what is reduced, you have to write copper oxide. Write the name of the compound. Okay, write the name of the compound.
Let's see question number 6, children. Give an example of a combination reaction which are exothermic. Just now we have studied about the calcium oxide. When react with water, calcium oxide react with water, it gives slag lamp, calcium hydroxide, and a lot of heat. So if we see, it is an example of exothermic reaction because heat is evolved here, and then it is an example of combination reaction because two reactants combine together to form one product. Okay. Now coming to the next question, here you have to identify oxidizing agent and reducing agent. Okay, oxidizing agent means these are the agent which helps in the oxidation of other compound, and reducing agent which help in the reducing of the other compound. Okay, so let's see the reaction. H2S plus chlorine gives you HCl and S. Now what is oxidation reaction? Oxidation reaction can be the addition of oxygen or the losing of hydrogen, right? So here what is happening to hydrogen sulfide? If I see here, I can see that hydrogen is removed from the sulfur, so this is a oxidation reaction. Okay, hydrogen is removed from sulfur, and this is the oxidation reaction. So which element or which compound is helping in the removing of hydrogen? Of course, chlorine is helping, because chlorine is the one which is getting attached to hydrogen, right? So chlorine is a reducing agent. Fine. Chlorine is a oxidizing agent. Losing a hydrogen, that is oxidation. So chlorine is a oxidizing agent, whereas what is happening to the hydrogen? The hydrogen which is released from hydrogen sulfide, it is accepted by chlorine. So chlorine is getting reduced. Now what is reduction reaction? Accepting of hydrogen. Reduction is accepting of hydrogen. Chlorine had accepted the hydrogen. That means the chlorine is getting reduced. And which compound is helping chlorine to get reduced? H2S is helping. Who has given the hydrogen? H2S has given the hydrogen. So H2S is a reducing agent. That's it. Okay. Now coming to the next question, name the phenomena due to which the taste and the smell of oily food changes. This is definitely a rancidity. Okay. When kept for a long time in open, suggest one method to prevent it. So we can use antioxidants, okay, to prevent the rancidity. Rancidity is a phenomena in which the taste and the smell of the fatty food or the fried food becomes change. Okay, why? Because it reacts with oxygen, and that's why this happens. So to avoid this, we can use antioxidant, and we can also use inert gases such as nitrogen is added to prevent the packed chips from getting oxidized. So we can add nitrogen to the chips so that oxygen can be removed, and then food can retain its taste for a longer time. Next question, 2 gram of ferrous sulfate FeSO4 crystals are heated in a boiling tube. First, state the color of the ferrous sulfate crystal both before heating and after heating. Okay. So ferrous sulfate we heat, and what we have to find out? We have to find out the color of the crystal. Before heating, the color is green and it changes to brown after heating. Name the gas produced during heating. As you can see, the gas produced during heating is sulfur dioxide and sulfur trioxide. Both sulfur dioxide and sulfur trioxide is produced. Write the chemical equation for the reaction. Even though it is not written balanced chemical equation, but children, whenever you write equation, it has to be the balanced one. Okay. So FeSO4 gives Fe2O3 ferric oxide, sulfur dioxide and sulfur trioxide. So we have to balance this equation. Iron is 2 here, so iron is 2 over here. Sulfur is 1 and 1, 2. Sulfur is 2 here, and oxygen is 4 into 2, 8 oxygen are there. Okay. So what about over here? 3 plus 2, 4, 5, 6, 7, 8. So hence this equation is balanced. Coming to the next question, write balanced chemical equation for the following reaction. Dilute sulfuric acid, that is H2SO4 sulfuric acid, react with aluminum powder Al. Okay, so now Al plus H2SO4 gives you what? It will give you Al2SO4 and hydrogen gas is removed. Why? Because metal react with acids gives hydrogen gas. Okay, and that too dilute. Dilute hydrochloric acid react with sodium carbonate Na2CO3, it is a carbonate. So react with acid, what will happen? Carbon dioxide release, water is released, and NaCl, the salt is formed. Okay, after that you have to balance the equation. Clear, children? Then coming, carbon dioxide is passed through lime water, CO2 passing through lime water is slake lime, CaOH whole twice. It will give you calcium carbonate. Actually, when you pass carbon dioxide to lime water, definitely a product is formed which is calcium carbonate, which is the responsible for the white PPT. Okay, precipitate. Fine. And definitely water is also formed. Now after this you need to balance the equation. Question number 9. Sodium calcium oxide, solid calcium oxide was taken in a container and water was added slowly to it. Calcium oxide CaO, water is added slowly to you, slag lime is formed, heat is generated. State 2 observation made in the experiment. Okay, write the balanced chemical equation in this reaction. So what are you going to observe? Yes, we will feel that the beaker has become really hot. Okay, and you will find a hissing sound, which is very important. These two observations are very important, children. Hissing sound, and the container becomes hot because the reaction is exothermic reaction. Coming to the next, uh, select combination reaction, decomposition reaction, displacement reaction from the following chemical equation. So it's very easy. Zinc carbonate gives you zinc oxide and carbon dioxide. There is one reactant and two products. So definitely it is a decomposition reaction. Okay. Then let's see this displacement reaction. Let's see the displacement reaction. Pp plus Cl copper chloride gives the PpCl2 plus copper. Yes, it is a single displacement reaction. Then NaBr and AgNO3 gives AgBr, right, and NaNO3. So definitely it is a double displacement reaction. We can see here. Hydrogen plus chlorine gases combined to it gives HCl, which is also a gas. So two reactant and one product gives me combination reaction. Okay, then Fe2O3 and aluminium. Okay, iron is replaced by aluminium, Al2O3. Al2O3, it should be O3, children, not 36. Al2O3 gives 2Fe, right? You can see, you can balance the equation. Okay, now this is a single displacement reaction. Iron is 2 here, iron is 2, oxygen is 3 here, oxygen is 3 here, aluminium 2, aluminium 2. Okay, so this is a single displacement reaction. And hydrogen plus nitrogen gives you ammonia, so it is a combination reaction. Calcium carbonate, which is solid, when you heat it, gives you calcium oxide and carbon dioxide. It is a decomposition reaction, and this decomposition is due to the heat. Okay, so this is, see the another question, children. This is the last question of this session, but a very important question. Name the substance oxidize and the substance reduce. Okay. Also identify the oxidizing agent and the reducing agent in the following reaction. The first one is manganese oxide plus aluminium gives manganese and Al2O3. Now manganese oxide, what is oxidation and what is reduction? Oxidation is gaining of oxygen, reduction is losing of oxygen. Now in this case, manganese oxide, is it gaining oxygen over here or reducing? Yes, it has lost oxygen. Okay, so from manganese oxide to manganese, this reaction is reduction reaction. Okay, manganese oxide to manganese is reduction reaction, and MnO2 is an oxidizing agent. Reduction reaction, MnO2 is oxidizing agent. Just remember, two different or two contrast things are taking together. Okay, aluminium is getting oxygen, so definitely oxidation is taking place. So from aluminium it has changed to aluminium oxide. So aluminium is what? It is a reducing agent. Okay, so this is how you can learn. Coming to the next, ferric oxide plus carbon monoxide gives you iron plus carbon dioxide. Here, did iron has lost oxygen? Yes. So ferric oxide to iron is a reduction agent. This is reduction agent, then ferric oxide is what? It is a oxidizing agent. Reduction and taking place between ferric oxide, it has changed to iron, and ferric oxide is oxidizing agent. See, oxidizing agent. Okay, and carbon monoxide,
because it has gained one more oxygen. So oxidation taking place between carbon monoxide and it is becoming carbon dioxide. Okay, oxidation taking place between carbon monoxide. So carbon monoxide, it is a reducing agent. Reducing agent, right? Now coming to sulfur dioxide and H2S, hydrogen sulfide. So if I see over here, sulfur dioxide changing into sulfur, that means losing of oxygen, that means reduction reaction taking place. Okay, so that means sulfur dioxide is oxidizing agent. Oxidizing agent, right? And sulfur hydrogen sulfide is changing into water. So hydrogen is getting oxygen over here, so changing into water, so oxidation taking place, right? So H2S, in this case oxidation is taking place, changing into water, so H2S is a reducing agent. Reducing agent, right? So this is all about today's session, children. Practice today's topic and thank you so much.